Hello students, welcome to the new module of our chapter called electrostatics. And students, in this particular module, we'll be focusing on the basics of standard 11. And in this particular module, we'll be focusing on the term called electric field and electric field intensity. Right? So let us start with the concept of electric field. Now student, we have already learned this concept in standard 11. Right? So what is electric field? Electric field is nothing but the space around any given charge. Right? So let's say I'm having a charge plus Q, and around this charge plus Q I'm having a certain space. Right? So let's say this is the space around charge plus Q. And if I place any other charge in this particular space, that particular charge will experience either a force of attraction or a force of repulsion. Right? So I can define electric field as the space around any given charge in which any other charge, right, let's say other charge is plus Q naught, will either experience a force of attraction or a repulsion. Now in this particular case, since both charges are positive, there will be a force of repulsion, right? So the space around any given charge in which other charge will experience force of attraction or repulsion is called as electric field. Right, students? Now this is nothing but the definition of electric field. Now student, if I consider this particular charge plus Q, now this particular charge plus Q is producing field, right? So that's why this particular charge which produces electric field is called as source charge. And this particular charge which experience the field, or rather which experience the force in field, that is charge plus Q naught, this particular charge is referred as test charge. Right? So while studying field, we'll come across two types of charges. First one, which is producing the field, it is referred as source charge, and the second one, which is experiencing force because of the field, that is referred as test charge. Right? Now let us move further. Now student, the strength of electric field, if I want to define strength of electric field, the strength of electric field is determined by a vector quantity called as electric field intensity. Right? And this strength is always determined at any point in the field. Right? So I can say strength of electric field at any point in the field can be represented by a vector quantity called as electric field intensity. And this electric field intensity is represented by symbol vector E. Right? Now let us move further. Let us define electric field intensity now. Right? So electric field intensity at any point in the field can be defined as force acting per unit test charge. Force acting per unit test charge placed at that point. So let's say I am placing a charge plus Q naught over here. Right? Now this charge plus Q naught is positive. Source charge is positive. So both charges being positive, there will be a force of repulsion over here. Right? So I can say charge Q naught will experience a force, and this force per unit test charge is nothing but our electric field intensity. Therefore I can say vector E is equal to vector F upon Q naught. Right? Now let us move further. Now this is nothing but the formula for electric field intensity in terms of test charge. Right? Now let us move further. Now if I say force, what is this force? In this case, it is nothing but a force of repulsion, right? And it is nothing but the force between two charges. And whenever I want to find force between two charges, I'll be using which law? I'll be using Coulomb's law, right? So let's say distance between these two charges is small r. And according to Coulomb's law, I can write the formula force is equal to 1 by 4 pi epsilon naught. First charge is Q, second charge is Q naught, and the distance is R. So the formula becomes force is equal to 1 by 4 pi epsilon naught Q into Q naught upon R square into unit vector R. And this unit vector R gives the direction. Right? Now I'll be putting this particular value of force in the equation of electric field intensity. Right? So once I put this value, I'll get vector E is equal to 1 by 4 pi epsilon naught Q into Q naught upon R square into unit vector upon Q naught. So I can cancel out this Q naught and Q naught. Right? Once I cancel out Q naught, I'll get the final expression as E is equal to 1 by 4 pi epsilon naught Q upon R square into unit vector R. And this is nothing but the formula for intensity in terms of source charge. Right? So students, in this particular module, we have learned what is electric field, At the same time, we have also learned what is electric field intensity, right? We have learned two formulas for electric field intensity. First one in terms of test charge, that is E is equal to vector F upon Q naught. And the second one is in terms of source charge, and the formula is 1 by 4 pi epsilon naught Q upon R square into unit vector, right? So students, make sure you are writing this particular formulas properly. That's it for this module. Till then, keep learning. Thank you.
ये पीछे